So basically, let's just run our program and just know what to do. So if you want to run the program, you just do start stimulation. So when you start stimulation here, you will see the LED blinking. Let's see, it is initializing. Sorry, it is keeping long because of my network issues. Alright, so I think by now it should be up. I think let's see if we have it seems there are errors here. I did something wrong. Let me close it and see. Error. I think, where was the error? Okay, yeah, I think, yeah, sure. Let's start simulating once again. Alright, so you see it's blinking. It turns on and off, if you can identify it from here. Alright, so that's how it works. Now we want to do this in Python. What can we do? So let me stop it. So we have a library called PyFormatter, which is a good library. You can install using pip, and we all know how to install packages using pip, which we have discussed in an earlier videos. You can go back and check. So using pip, we can use our board, write similar code, and then just compile it to our Arduino board to work the same way. Alright, so when we come here, there's one thing let me show you before we move on. You see, we can initialize our serial port. So we can do something like serial begin, and just initialize our board 19200, and just use copy. Let's see something right from here, V, and just write hi, which is for so we write our hi, copy, and we come here, we write our low. So if we do this, this would help us initialize whatever is going on in the board, like whatever is going on. So now we see high, low. Let's do something. You can do this to bring it on. Is it back end? Let me stop stimulation and then just do back new line, backslash new line. Alright, let me start simulating again. Alright, so you see now it's going down just because I do backslash new line, which is also in Python. So you see it's moving on and off, on and off. So this is what we are going to implement in our Python code. Alright, so let's get started using our Python code. I don't want this to be a long video, so let's get started. Now, for you to start, you need to go to your Arduino board, Arduino IDE. There is something in here called PyFormatter. If you don't find it, you need to go to your tools and just go to the manage libraries and just go and install PyFormatter. But normally, sometimes it's in here, it's in the example, and just go to the formatter. Just load the standard formatter. When you load this, you just compile to your board. Now I have inserted some board port in my PC, so you need to do just that. I'm using the Arduino Uno. I'm having the Arduino Uno right here, so I just compiled this to the board. I have an error here. Let me see what is going on. I think servo. Oh, let me use servo. No, I don't have to use. Okay, come in a moment. I think I have to know. So example formatter, standard formatter. Let me see. Okay, then I have to install manage libraries and just go and install the servo. This will take time. I didn't know this wasn't installed. Alright, so you just come here and it's loading, updating my libraries. So as I said, you just need to come here and just to do the servo. In my case, servo, but in your case, you need to do the pi formatter or formatter. So servo is here. I need to install servo. Alright. So as we wait for servo to install, I'll just walk you through the next step. I think I have errors due to my network, so I have already installed it on my board, so I don't actually need it, but I was just trying to compile it so that you will see. So if it's not compiling, let me close it. I already have it, so you can go ahead and do it. Alright, so I will go ahead with the code. So now if you install that, you need to start up a new project. Alright, in my case, I have a new project here. By ls, you see the environment here. That's where I have kept the code. So if I cd2 environment, alright, I have some code in here. Let me ls. We have the main, we have the pip. So this is where you are going to install, but first you need to do your environment variables first. You need to assign it. Alright, I think Mr. I can't remember the name, sorry. He taught us, so you need to refer back, know how to work with environment variables. So I'll initiate my environment variable right here. I use pipenv, that works for me, so I'll initiate it right here. So it's being activated, and now we need to get into our code. So you need to install the pi formatter. So you do pip install pi formatter. I have already installed it, so I think it will just give me the message that it's already in the system. Let's see. I have some network issues, so it's already in there. I have network issues, so that's why it's retrying. Let me stop it. I already have it. Alright, so I already have it here. My network is really bad, right? So after you do that, I will just run the code in VS Code. So this is how I'm going to do it. So we have the main function here where we are going to run our first code. So first of all, we import our formatter, and then we import sleep, as we learned earlier, sleep from Python. Pi formatter also has a sleep function in there, but we are not going to use it today. Alright, so we import sleep. Now we need to initialize our port, which is the computer port that we are using, which is the USB slot there. So you need to initialize it where the program will be compiled through the board. Right, after that you come and initiate pi formatter Arduino. So this is the board that you are going to use, Arduino board, and then you fix in the port. So it's like fixing Arduino board into a port, all right, computer port. All right, now we use the while true. While true will be like the loop function that we saw in the C++ program. And then we move on to the digital write. So we initiate the board and then put on the initial we have the board here, and we have our method which is responding to the boards, which we are using the digital. We have digital readings and we have analog readings, and for the two readings we have read and write. All right, so now we want to write to the board. That we are getting digital pin 13, and then we are just writing it to the board. All right, so after that we just print to the console that, oh, like we have a code running, and then this code is saying it's giving us an output of high. All right, then we sleep for 0.5 seconds. All right, which is half a minute. All right, which is 500 milliseconds. Sleep here is coming from the time. So instead of us to use the time.sleep, we have shortened it right